So, equations and units used per topic. We have under here, we have under mechanics, we have density, force, moments, or work done. We have a bit more, it goes on. You have speed, velocity, acceleration, momentum, kinetic energy, potential energy, and then you have power, efficiency, pressure, and pretty much that is where we end for mechanics. So of course we're going to deal with them in pieces, where we have the measurement, and we have the equation, and we have the units. With density is equal to mass divided by volume. You can have units of kilograms per meter cubed or grams per centimeter cubed. It's pretty cool. This is when you deal with smaller units, and this is when you deal with bigger units. We have force. We have 3 equations representing force. The first one deals with weight, because weight is a force. Weight acting on the earth or acting on a body that has gravity pulling on your body. And the M stands for mass, G stands for gravity. So mass times gravity is equal to your weight, because we all know weight changes but mass does not. Force is also equal to mass times acceleration. And force is also equal to constant times extension. And you deal with this when you're dealing with springs. This one is dealt with when you're dealing with acceleration. Like if you hit a ball with a bat, or you're going to kick a ball, you deal with that. Then you have moments. Moments are the work done. Moments is the amount of force you extend based on distance, right? And you can determine the moment of something by multiplying its weight by its distance. And that one has units of Newton meters. 1 Newton meter is equal to a joule. It's pretty cool to know all of your equations beforehand too, so this is really good. Now, here we're dealing with speed. Speed is equal to the distance covered in time, and we have units of meters per second. Velocity is the distance in a stated direction done so in a certain amount of time, and it also has the same amount of units. It has the same type of units as speed. The only difference is that one is a vector and one is a scalar. Vector means that you have direction and size. This one, scalar, means you only have size. There's no direction when it comes to speed. So acceleration is equal to velocity over time. The units used are meters per second squared. Momentum is equal to mass times velocity. The units are kilograms per meter per kilogram meters per second. Then you have kinetic energy, where you have a half mv squared, or you can say mv squared over 2. It's the same thing, measured in joules. Anything with energy is measured in joules. Then you have potential energy, where you have the mass times gravity times height, measured in joules as well. Power is equal to the work done over time, and this has units of joules per second. 1 joule per second is equal to a watt. Efficiency is the percentage of work done by load per effort times 100%, because you're dealing with percentage. That is how well a motor works. The efficiency of a motor is never 100%, never over 100, right? Because energy is always lost to the surroundings. And then you have pressure. You have 2 equations of pressure. You have force divided by area, meaning whatever is acting on that area will give you pressure. And you have density times gravity times height. Usually deal with this one when it comes to water. Units of pascals. And pretty much that's mechanics for you.